With me today, I have Mike Morris, Senior Director of IT at NetApp. He's in charge of CloudOne, the DevOps platform inside of NetApp that provides all the cloud services, automation, and continuous integration, continuous deployment release models that NetApp application development teams need to build cloud-native applications. Mike is here today to share lessons learned from NetApp's deployment so that you too can use a DevOps cloud platform that reduces costs, increases speed of application development, and allows developers to focus on writing code. Mike, tell us about CloudOne.
Thank you. Yeah, so I love talking about CloudOne to infrastructure and cloud leaders like myself, because this is really the future of enterprise infrastructure teams. If you think about enterprise IT organizations, they have infrastructure organizations. The really future of those teams is building platforms like you're going to see today that we've done with CloudOne, so you can continue to service application development teams and the needs they have for platform, cloud, and infrastructure needs. So CloudOne is our hybrid multi-cloud platform to service application development teams, and particularly doing that through DevOps. The name comes from Customer One, which is one of the roles of my organization. So we are early adopters of NetApp technology, and we run NetApp products in production IT. So we're not the product QA or not the product development organization. We are enterprise IT, and we use NetApp products in production running our critical business applications. So the name CloudOne comes from being Customer One of our products. It's also the one-stop shop for services. If you look at the infographic on the right, you'll see in the top row there's the 4 services that we offer on CloudOne today in white. The DevOps service, which I'll talk about today, that provides the complete developer experience, everything development teams need to be productive in writing code and releasing changes to their applications. We also offer Container as a Service, which is for pre-built containers that can be then deployed through the same automation. We offer PaaS Marketplace, which exposes public hyperscaler capabilities like Lambda, Database as a Service, and other capabilities. And then we have Infrastructure as a Service if application teams just need good old VM storage and networking. And we have one consistent user experience irrespective of the cloud destination. And that's important, that regardless of what service the software development teams want to use, when they come to CloudOne, they get one consistent user experience, whether they're using the DevOps service, the CAS service, or the other services we offer. Now, we've been on this journey for quite some time. This started prior to 2015, where I'm sure most of you have been in the past, where we did hardware standards and DC consolidation through virtualization. We also got established with build standards on our first taste of automation, so we could build infrastructure environments using automation. And that led to our first infrastructure as a service cloud, which is not CloudOne, but it was our first cloud environment in NetApp IT, and it was an infrastructure as a service offering that we could deploy an infrastructure landscape in public or private cloud in about 15 minutes. It had a self-service catalog, and we were very proud of that first cloud. Unfortunately, we did not get the usage from our application teams that we expected because it didn't offer them all the capabilities they truly needed. We learned a lot from that first cloud, and that led to the things we built in CloudOne today. So as you'll see, CloudOne is a platform for cloud-aware application architectures running containers. So that means microservices-based design that fit nicely in containerized environments. We provide a full DevOps CI/CD automated app deployment, and we are using NetApp products in our private cloud like NetApp HCI and all-flash FAS. And we've continued to mature CloudOne over the last several years. So today, we run Tier 1 applications in production on our platform, and I'll talk about that in the slide coming up. And we're going into the future. We're expanding our service catalog. We're looking at service mesh so we can dynamically use multiple public clouds. And we're building advanced application release models. Just recently, we deployed what's called Canary software releases into the CI/CD process in CloudOne. So CloudOne is a platform now that we continuously improve and add capabilities to continuously service the needs of our software development teams. So before we jump into CloudOne itself, I do want to talk about DevOps in the enterprise. And this is important because ultimately we've built CloudOne today so we could do DevOps in enterprise IT. So there's a couple major business trends that we see impacting IT organizations, and those two trends are SaaS for business applications, but DevOps for applications that redefine your business. So on the traditional IT side, you get to run the business applications. Things are ERP and HR platforms and sales operations, and these are not giving you competitive advantage, but still very important. So the key here is to make sure you simplify business processes so you can adopt SaaS services in cloud. So things like SAP Cloud or Office 365 or ServiceNow, those companies have already automated common business processes which are much easier to rent than try to build yourself. And the other major trend is the DevOps trend, and these are the applications which do give you competitive advantage and allow you to service your customers in new ways. In this case, you're looking at rapid software development using dynamic cloud services. Those clouds could be public clouds like AWS, Azure, and GCP, and it could also be a private cloud. And what you really want to do here is build the applications which give you a competitive advantage in the marketplace. Because what we're ultimately trying to do is get IT to run at the speed of business change. And to achieve that, we really need to have rapid and frequent delivery of business software capabilities. So we really want to get away from the traditional IT way of application releases. And in NetApp IT, we still have plenty of applications that do it this way. But this way is very slow, and it's also very risky because you're putting a lot of changes into infrequent releases. So you have a release in February, then you wait 30 days and have a release in March, and then in our case, we don't do anything in April because that's our end of our fiscal year. So we have 60 days before any new application releases can be deployed. That's very slow in servicing your internal employees or your customers, and it's also very risky because you're putting probably hundreds of changes into those releases. Now, years ago, we came up with Agile IT, which, as I like to say, was just a better way to organize the humans. It was a better work structure that allowed people to prioritize and deliver application releases on a more frequent basis. In this example, we're doing an application release every 2 weeks. One of the teams that works for me uses a 2-week Agile sprint methodology, so we have every 2 weeks we release changes to our application. What we want to get to, though, is DevOps. And what DevOps does is it combines Agile practices with the speed of cloud and automation. So we can do our application releases daily, hourly, and when we really get good at it, we'll just do it continuously. Thus, the continuous integration, continuous delivery aspect of CI/CD. We want to be able to continuously move changes to production to be able to respond to changes that our business has. Now, how we're going to do that is through those two trends we see. So on the SaaS side, we're going to take the traditional IT processes of business process automation, sales ops, HR, and move those to SaaS. In our case, on the DevOps side, these are the applications which are unique to NetApp and give us competitive advantage. And when we talk about DevOps, we mean the close interaction and functioning between application dev and application ops. And the key to DevOps is getting those two different functions in an IT organization to work together in a coordinated way so they can do rapid software delivery. Now, the key to this, though, is these DevOps teams, even if they're working well together, they still need automation and cloud technologies to be able to go fast. And if you don't provide it to those DevOps teams, they'll generally go get it themselves. They'll go to public cloud providers, they'll go to lab environments, whatever they need to do to get the automation and cloud technologies they need. So what we did in my team is we built CloudOne to service the DevOps teams. So in CloudOne, we're providing all the automation and cloud technologies that the DevOps teams need so they can be productive day one. And they can stay focused on writing code of their application and delivering those changes to production. If we look inside of CloudOne, we can see some of the products and technologies that make up the platform. And our job in creating and running CloudOne is to select these products and integrate them together to create services that the DevOps teams need. And those products are things like industry technologies, which I'm sure many of you have heard of, things like Docker containers and OpenShift or Kubernetes, and then the cloud providers themselves. And also NetApp products are key to the platform, whether there's things like Cloud Volume Services or NetApp Trident or private cloud technologies like HCI and All-Flash FAS. All these different technologies are integrated together by my team to create CloudOne, in servicing the DevOps teams. And the other key thing to consider here is tying the DevOps strategy to our application portfolio. Our application portfolio, NetApp IT, is maintained by our enterprise architecture team, and they use the Gartner time model to categorize the applications in our portfolio. On the left-hand side are the tolerate and eliminate applications. Those are the applications that we're just keeping around or trying to get rid of. On the right side of the quadrant here, though, is the applications which we think about as we move into the future. So invest strategic are the applications we like and want to do more with, and migrate are the applications which still provide critical business functionality, but the technology is old, maybe the application is old, or the infrastructure is old, or whatever it's built on, and we need to migrate that to new technology. So our EA team has looked at this portion of our portfolio and decided that over the next 3 to 5 years, they see about 70% of our application portfolio going to software as a service. And that's important because we run in NetApp IT a lot of the run the business applications for the company. We run the HR platform. We run the customer relationship management platform. We run the sales ops platform. So instead of trying to build those common business processes ourselves in software, we're just going to go rent it from a SaaS provider. But that does leave about 30% of our future portfolio, which are custom applications. Those applications will give us competitive advantage. And when we decide to build those applications, we're going to build them on CloudOne. So building out our hybrid cloud, first we have the SaaS providers, and this is just an example of some of the ones we use. But again, common business processes which have already been automated by SaaS providers, and we're just going to rent those services from those cloud providers. The other 30% is then serviced by CloudOne, where we take the public clouds and our private cloud, and we've created a software-controlled and orchestrated development platform so we can build and run cloud-aware applications using DevOps. And that's going to solve the other 30% of our future application portfolio for the custom applications. And then finishing out our hybrid cloud, at NetApp IT, so we have CloudOne for the custom applications, we have SaaS for our common business applications, and we still have our traditional data center. We still have to consider the integration points to our tolerate applications, that one portion of the application categorization that will be with us for quite some time. And what this ultimately leads to is what I like to call the realistic cloud-first strategy. So it's not just saying we're cloud-first. We have a methodology behind how we adopt cloud. So on the top left-hand side there, you look at application rationalization. So things that are applications which are commodity or systems of record, those are applications which are probably going to go to software as a service. Applications which provide us innovation or differentiation, those are probably custom applications, and that's where CloudOne comes into play. So we apply this rationalization on a case-by-case basis to each application in our portfolio. And then for each application, we can decide which cloud the application should go to. Maybe the the software is good, but it needs new infrastructure. That's infrastructure as a service. Maybe the application needs to be completely rebuilt into microservices and containers. That's CloudOne DevOps, which I'm going to talk about more today. And then for a majority of our applications, we're going to replace that application with software as a service. And this is the methodology that our enterprise architecture team goes through on an application-by-application basis to drive change in our application portfolio. Okay, so now that we've understood how DevOps fits into our cloud and application strategy, now we can start to delve more into CloudOne itself. The original vision of CloudOne was a cloud-based, full app stack automated platform for DevOps application creation and operations. And that's important, that not only do we create the applications on CloudOne, but we operate them on CloudOne. So 4 goals we had for CloudOne. First, increase the speed of application change delivery to meet rapidly changing business needs. That goes back to the slide where I showed the 3 different ways that you can deliver application changes. And the old way of doing it once a month or once a quarter, way too slow and way too risky. So we want to increase the speed of application change delivery. Second, focus developers on writing code and releasing application changes, not dealing with other IT services. Software developers are very expensive, limited resources. So we don't want them to have to spend 25 to 30% of their time dealing with other technologies, dealing with AWS virtual machines, dealing with Kubernetes, provisioning storage, all those type of things. We want to automate all those type of capabilities so the developers can stay focused on writing code and releasing changes to their application. And then provide the automation for frequent, but small production application changes to reduce the production deployment risk. One of the problems with the traditional way of doing application changes is not only is it infrequent, but it's also risky. There's hundreds of changes that go into one software release, usually at 2 a.m. on a Saturday night. So in CloudOne with DevOps, we want to do frequent, almost daily, hourly, or constantly changes production, but we do those changes, we want to make sure they're small in nature. And then reduce costs by using open source application stacks and dynamic cloud services. Next thing we'll talk about is DevOps maturity model, and this is important so you can measure where you stand from a DevOps perspective. Level 1 DevOps, and you can see some of the characteristics of level 1 DevOps. The best way to describe that is if you say you're doing DevOps, but you really are doing the bullets listed in that row, I kind of joke and say you're lying to yourself. You're not really doing DevOps yet. When you get to level 2, repeatable, and you start to do some of those things, that's really pockets of DevOps. So you're not really coordinated across all the different capabilities required to do end-to-end DevOps, but you're doing some good things. You got some automation builds, you got some standards being created, maybe doing pockets of DevOps in certain teams. When you get to level 3 is where you really start to hit your stride. And the key bullet there in level 3 defined is processes automated across the software delivery lifecycle. So can you take a change to source code and propagate that change through a regular automated process all the way to production? And then you get the advanced levels of maturity, level 4 DevOps and level 5 DevOps. And I see some different names that you can apply to these levels that we use ourselves. We were at level 3 continuous delivery up until the end of April when we released our advanced software delivery capabilities, the Canary release as I mentioned before, which got us to level 4 DevOps continuous deployment. And right now we're working on capabilities in the CloudOne platform so we can move to level 5 DevOps in the next 9 to 12 months. So it's a good maturity model you can look at key characteristics of each of those and determine where you fit in a DevOps maturity model. All right, now that we've kind of talked about the background and vision of CloudOne, now we can get into the architecture and some of the more fun technology components of the platform. First, though, let's talk about dealing with tools and technology selection, because there is the challenge of getting sucked into all the different tools and capabilities out there. You got to have some principles to making decisions on what tools you want to use in a platform like this. So the big thing is focusing on providing end-to-end solutions as a service. Okay? And there's 4 key principles we think about. First, it's a service. You're ultimately building capabilities in an automated platform to service someone, and are those services something that people want to utilize? Second, developer productivity. If you're going to build a DevOps platform, you're really talking about how do you make developers more productive and giving them the tools and capabilities so they can act fast and deliver that rapid software changes. Third, security built in. So as you're building the orchestration that developers rely on, build security into that orchestration. And I'll show that some of that coming up. And then one of the key things we always think about is using both public or private cloud, but staying cloud agnostic. And we've been able to do that through our use of containers to deploy applications into public and private cloud, but keeping our flexibility. So these 4 principles are what we use when we're considering tools to add to CloudOne. Now at a high level, this is the DevOps architecture in CloudOne, which is made up of 3 major components. First, you have the developer tools. As the CloudOne DevOps service is the complete developer environment, we provide the developer tools to the DevOps teams. The primary ecosystem our development teams use is Azure DevOps, and that's a SaaS service from Microsoft that Microsoft uses themselves to create Microsoft products, but you can license it and use it for your own software development teams. We also provide application stacks that the apps teams use to build their applications on top of. So some examples like Spring Boot and Nginx, or databases like MongoDB, we provide as part of the platform. So again, the software development teams have everything they need to begin creating their applications. You combine the developer tools with the platform software. This is where a lot of the automation comes into play. So in the DevOps service, all applications are in Docker containers, managed by OpenShift, defined by Helm charts and customized I/O. We use NetApp Trident, which is an integration into OpenShift to do storage provisioning. And then we use JFrog's Artifactory for binary management, all automated by a lot of Ansible automation. And we combine that with infrastructure as a service, and that's public cloud and currently to the AWS. Because the developer tools, the platform software, and the Blue Circle software, the actual applications, those all need hardware to run on. And we get that hardware from either the private cloud or the public cloud. The key principle in this is end-to-end automated DevOps workflows. Again, going back to our second goal, we want to keep developers focused on writing code and release these changes to their application, not dealing with other technologies. So as developers are working on their software, I don't want them to have to stop and log into OpenShift and create a project or go back to their code and then stop, they got to go to AWS and create some more virtual machines. We want to try to automate all those capabilities inside the platform so the developers can stay focused on writing code and releasing changes to those applications. So that's a high-level view. Now we're going to get a little more deeper in the architecture. In CloudOne, there's 2 days to consider. Day 1 is where we onboard an application onto the platform. Day 1 runs once per application. It takes about 20 to 30 minutes to run. The Day 1 automation is ultimately trying to create what we call a DevOps workspace and a DevOps host space. If you look at the top right-hand part of this slide, you can see the workspace and the host space. The workspace is a logical environment on the platform for that individual application. And the workspace is the non-production part of the application. It's where developers are doing their work. They're doing dev test environments, they're creating new features, they're trying things out. It's a workspace. The host space is where the application runs for real, both the stage and the production instance of that application on the platform. And as you'll see on the next slide, the CI/CD process will ultimately migrate changes from the workspace into the host space. And then we also offer databases as a service in the data spaces. So if applications need a database, we also can provision those. But to get to those environments there on the top right, we have to run the Day 1 automation. That begins on the left with the self-service catalog in ServiceNow. Development teams go into the self-service catalog, they select the environment they want to use, the application stacks and the sizes they need, and then they submit that workflow. The first thing that happens in the workflow is we update the configuration management database in ServiceNow. That's important because we want to make sure we track all of the assets, physical and logical, that get created by our automation. Next, ServiceNow hands to Ansible Tower, and Ansible automation runs 4 major playbooks. The first at the top there in the middle is we configure the Docker repository for the application. So in Artifactory, all the applications through the CI/CD process will create binaries, and those binaries need to be managed, and that's what JFrog's Artifactory does. Next, we use an internal tool called Neat to create email lists, and then we use those email lists later to do role-based authorization in other parts of the platform. And role-based authorization through Active Directory is important because we don't want just any Joe developer to make a source code change and then he himself approve that source code change all the way to production. So there's different roles we need as we go through the software delivery lifecycle that you'll see on the next slide. Next, the Ansible playbook configures the OpenShift environment for the application. And then finally, we configure the Azure DevOps environment, and this is the developer ecosystem for that application. So things like code repositories, branching policies, and actually the CI/CD process itself. That entire Day 1 automation, again, takes about 20, 30 minutes per application. It runs once, and at the end of that, we now have a DevOps workspace and a host space on the platform for that individual application. That then allows the application teams to move to Day 2, which is where the actual software development is done and the CI/CD process runs. Now the slide's a little busy, so I orientate everyone to it before I go through the process. At the top row is Azure DevOps. That is the primary development ecosystem the development teams will spend most of their time in. The middle row is the build environment. We're ultimately going to build the application using the source code and the application stacks. And at the bottom row is the operating environment of the application. On the left-hand side of this diagram, you'll see a light gray box that goes around the three rows. If you look at the far left-hand side, you'll see a label there that says DevOps Workspace. If you remember the previous slide, the workspace is the non-production part of the application. So this part of the CI/CD process, the CI process, is the workspace. Ultimately, deploying those applications in the containers managed by OpenShift in AWS. So in our environment, all non-production parts of the application, the workspaces, we run in the public cloud. On the right-hand side of the diagram, you'll see a slightly larger gray box, and the label there says the DevOps host space. This, as you can see in the bottom row there, is the stage part of the application and the production, the PRD part of the application. That, again, running containers managed by OpenShift, but now in our private cloud, and that private cloud being built on NetApp HCI and NetApp All-Flash FAS. So that's how the architecture of the CI/CD process is set up. Now what I'm going to do is walk you through how a change is propagated from source code all the way to production. That begins in the top left-hand corner of the slide where you have app source code. So a developer makes a source code change, again, hopefully it's a small change, and then commits that source code change to the source code repositories in Azure DevOps. That commit of the source code change begins the CI automation. What happens there is we take the source code change, combine it with the app stacks that were provisioned during day one, and run a build process. And that build process goes through a series of steps, including some security steps. That build process generally takes about 5 to 7 minutes, and then that portion of the changed application is deployed in the dev environment, again managed by OpenShift in AWS. So within 5 to 7 minutes, a developer can see a change they've made to the application running in non-production. And at this point, the pipeline pauses because we want to allow the developer to take however long they want to work in the workspace. They may be testing out new features, evaluating a new capability, whatever they're doing. Now, at some point, the developer is going to be satisfied with the change they've made in the workspace, and they are going to go to the next step, which you can follow the arrow goes to code changes approved. This now transitions the CI/CD process from CI to CD. Now, this is where role-based authorization is important. At the code change approved, someone with the role dev lead has to log into Azure DevOps, review the change, and approve it. So now the developer cannot approve his or her own change, the development lead has to, and that's usually the DevOps manager. Once that approval comes in, now the automation begins again, and we deploy the application changes into the stage environment. At this point, we have final test and ops approval. We do pause the pipeline here in case the application teams want to run advanced tests like load and performance, UAT integration. Most of the time, though, if they're making small incremental changes, they don't need to. And then there's a final ops approval. Because this is DevOps, we want to make sure that operations has the final approval on moving to production. So someone with the role ops logs into Azure DevOps, reviews the change, and approves it. When the approval comes in, then the automation resumes, and the application change is propagated to production. And now the production application has been updated, again, running in containers managed by OpenShift in our private cloud built on NetApp HCI and All-Flash FAS. This process of making a source code change and propagating that change all the way to production can be done in about 20 minutes. And I've done it myself for some of our applications. Now, most application teams will not go that quickly. They either will do daily changes, maybe they'll do hourly if they need to. Some do weekly. It's however fast they want to go. But the platform, CloudOne, provides them the ability to do changes to production in 20 minutes. Now, since we are customer one, we also need to consider the NetApp products that power the CI/CD process. So if you look at the diagram there, in the middle row, which was the build environment for the application, we use things like JFrog's Artifactory and Helm charts and stuff. But once that build is done, a binary is created, and that binary has to be stored somewhere. And we use NetApp Storage Grid to store our binaries. At the bottom row, which was the operating environments of the application, if you remember on the left-hand side, that was the workspace, the non-production part of the application. In that case, any container that does what's called a persistent volume claim, essentially wants to create a persistent storage environment, that persistent volume claim, which is inside of OpenShift, is captured by NetApp Trident and provisioned onto NetApp Cloud Volume Services for AWS. On the right-hand side, which again was the host space where the stage and production environments run, that environment is built in our private cloud for using NetApp HCI for compute, and again, NetApp Trident for storage provisioning onto NetApp All-Flash FAS. One of the things we've done since releasing our first version of CloudOne is continuously improve the platform, adding new capabilities, adding new features, and improving its maturity and operational resiliency. one of the key things we achieved last year was having Tier 1 application readiness. And Tier 1 applications in NetApp IT are our most critical applications. Those are things that we rely on 24/7 to either sell to customers, support our customers, or deal with our financial statements. So what we did on this readiness journey is we looked at the different components that make up the CloudOne service architecture, things like our DevOps catalog automation, container management in OpenShift, developer tools, storage and data management, all these types of capabilities that make up the services in CloudOne. And we looked at and said, how can we improve our processes? How can we improve our stability and resiliency? And how can we give operations more visibility and training? Because what we wanted to do is move beyond just running Tier 3 and Tier 4 applications and now run our most critical applications on CloudOne, those being our Tier 1 and our Tier 2 applications. We completed this journey last October, and now today we have a substantial amount of Tier 1 applications running on the platform. The best example is the NetApp support site. So hopefully some of you are NetApp customers and have used the NetApp support site for either knowledge base articles, open cases, downloading firmware, whatever it is. But that is a critical Tier 1 application that is built using a microservice design on CloudOne in production operations today. If any of you have your web browser open right now, if you go to support.netapp.com, the NetApp support site will come up, and that's an example of a Tier 1 application built and running today on CloudOne. And then just to give you some examples of what CloudOne is for us today. So not only is it the NetApp support site, but there's actually 55 applications today that run on CloudOne. And you can see the different tiers that make up the applications. So the critical applications, the Tier 1 applications, there's 9 of them today, the support site being one of them. And you can see the different types of applications that run on the platform today also. And the right-hand side is just some examples of applications that run on CloudOne today and the different components that make them up, the databases, the host bases, the microservices, and the workspaces that make up those applications and what they're using on the platform today. So this has become a critical application platform for NetApp IT. And I'd just like to finish by talking about achieving the goals. So did we increase the speed of application change delivery to meet rapidly changing business needs? Yes, we did. We can deploy changes, if necessary, from code submit to production in 20 minutes. And again, application teams don't generally go that fast. They can choose at what speed they want to go. But giving them the ability to go extremely fast is what we wanted to achieve. Next, focus developers on writing code and releasing application changes, not dealing with other IT services. Yes, we achieved that. Almost everything the developers need is automated by CloudOne. We provide them Azure DevOps. We provide them the CI/CD pipelines. We provide them the application stacks. Even underlying at the virtual machine level, we grow and shrink our virtual machine capacity automatically through Ansible to ensure that we always have enough capacity for the applications. Then provide the automation for frequent but small application changes to reduce production deployment risk. Yes, again, we're doing frequent. You can do them in 20 minutes at whatever pace you want, but hopefully doing small changes, keeping in principle of the DevOps, or keeping in line with the DevOps principle of making small changes but rapidly moving those changes to production. And then reduce costs by using open source application stacks and dynamic cloud servers. So as you saw some of the application stacks like Mongo and Nginx and those type of things, and then using dynamic cloud services, particularly in the non-production part of our environment where our workloads are very variable. So we run those variable parts, the non-production parts of our applications, in a dynamic public cloud environment.